Hello, today's topic is iron carbon phase diagram. So let us first construct the iron carbon phase diagram. For that, we have temperature on the y-axis and we have the weight percentage of carbon on the x-axis. And on the left side of the diagram, we have 100% of iron, and on the right side, we will consider for the iron carbon phase diagram until 6.67 weight percentage of carbon. Now let me draw the outline of the diagram. So this is the basic outline of the diagram. Now let's mark the different points A, B, C, D, E, F, G, H, I, K, L, N, P, Q, S. Now the different lines that I have just drawn on the diagram, each of these lines represents phase boundaries. So in between these phase boundaries, we have different phases. So now I will mark these different phases first. Here we have the alpha phase, which is called as ferrite phase. Here we have gamma, which is the austenite phase. Here we have the high temperature delta ferrite phase. Beyond this, everything is liquid phase. If I look at the phase at here, we have gamma plus L. So in order to obtain this, we need to consider the phase boundaries here and here. Beyond here, everything is liquid, and beyond this phase boundary, everything is in gamma. So in between, we will get gamma plus L. Now similarly, here we will get liquid plus Fe3C, because this line represents Fe3C, and this lines beyond this, everything is liquid. So here we will get gamma plus Fe3C, and here we will get alpha plus Fe3C. Here we will get alpha plus gamma, and here we will get delta plus gamma. Here we will get delta plus L. Now let me mark the most important points. Weight percentage of carbon. Here we have 0.02 weight percentage. Here we have 0.16 weight percentage, and here we have 0.8 weight percentage. Around here we have 2.06 weight percentage. Around here we have 4.3 weight percentage. Now in order to mark the different temperatures, I will first mark this line. This line is known as the eutectoid line, and here the temperature is known as A1 temperature, and it is around 723 degrees Celsius. And a little above we have the A2 temperature, that is 769 degrees Celsius, which is called as the Curie temperature. And at point G we have A3 temperature, that is 911 degrees Celsius. At point N we have A4 temperature, that is 1392 degrees Celsius. This line is called as the eutectic line. Temperature is 1147 degrees Celsius. And this line is the peritectic line. Here the temperature is 1493 degrees Celsius. And at point A we have 1536 degrees Celsius, which is the melting point of iron. Now we had to understand, based on the carbon content, we can classify steel and cast iron. From 0 to 2.06%, we have steel, and from 2.06 to 6.67% we have cast iron. And for steel and cast iron we can also classify them additionally. For steel, from 0 to 0.8 we have the hypoeutectoid steel, and from 0.8 to 2.06% we have hypereutectoid steel, and from 2.06 to 4.3 we have hypoeutectic cast iron, and from 4.3 to 6.67 we have hypereutectic cast iron. So these are the basic things that you have to learn from the iron carbon phase diagram. Now let us write the most important phases in the iron carbon phase diagram so that it is easier to grasp. Okay. So for that I will draw some columns. Phase, different crystal structure of the phases, and the maximum carbon content, here the name or designation. Okay. So first we have the alpha phase. It has a BCC crystal structure, that is body centered cubic, maximum carbon content 0.02 at a temperature of 723 degrees Celsius, and is called as ferrite. Then we have gamma, which has FCC, face centered cubic structure. It has a maximum carbon content of 2.06 at a temperature of 1147 degrees Celsius. It is called as austenite, phase of iron. Then we have delta phase. It also has a body centered cubic structure, maximum carbon content of 0.1 at a temperature of 1493 degrees Celsius. It's called as delta ferrite. Then we have theta, which is cementite Fe3C, and it has a orthorhombic structure and 6.67 carbon percentage, and it is cementite. Then we have this phase is not shown in the iron carbon phase diagram, but we are still writing it, which is the carbon. It has a HCP crystal structure, 100% carbon. It is called as graphite. Okay. Now let us write about the most important reactions. Important reactions on the iron carbon phase diagram. So first we have the peritectic point, that is point I. Here we have the peritectic reaction. The peritectic reaction is like this, where gamma plus L upon cooling down gives, delta plus L upon cooling down gives gamma. So it can also happen in a reverse way, that is gamma upon heating gives delta plus L. So it is a reversible reaction. Okay, now we will write it in a separately. So reaction number 1, peritectic reaction. At point I, we have delta plus L giving gamma, temperature 1493 degrees Celsius, and a carbon content of 0.16% carbon. Now the second reaction. It is the eutectic reaction. The temperature at a point C. Here liquid upon cooling down gives gamma plus Fe3C. So that is the eutectic reaction. So we'll write it. Eutectic reaction at point C, liquid at a temperature of 1147 degrees Celsius and 4.3% carbon gives gamma plus theta. Theta is Fe3C, and this altogether is called as ladybirite. Ladybirite will be detailedly explained in a different video. And at the third reaction is the eutectoid reaction, and it happens at point S, where gamma upon cooling down gives alpha plus Fe3C. So we will write it. Point S, gamma upon cooling down set 723 degrees Celsius, and at a carbon content of 0.8% carbon, we will get alpha plus theta, that is pearlite. So these are the most important reactions that is happening in an iron carbon phase diagram. So hope you understood until this point. And these are the basic things that we have to learn from the iron carbon phase diagram. If you like this video, please subscribe to my channel and like. And if you have any doubts, you can ask me in the comment section. Thank you.